Hey guys, Robo Theory, and I'm back with my fifth video, I think. And I haven't been putting on some content for a while, but I'm gonna continue. So today I'm gonna be talking about sensors in depth. So in this video, I'll be explaining the different types of sensors and how they affect a robot's decision based off the environment. So yeah, I'll be giving kind of an overview and more of an in-depth on sensors about stuff that you might have known, may not have. So let's talk about what a sensor is, just for review. Sensors are robots' basically eyes and ears. They receive input from the surrounding and send it to the brain to process. So the brain might ask for specific input, for example, the distance sensor over here. This distance sensor, the brain might ask for input from that distance sensor. So then the sensors have to take the input and then send it back to the brain. So why we need sensors is actually a really important question to think about. So let me answer it. So why we need sensors is because humans only have 5 senses, which is like the ability to see, taste, hear, smell, and touch. Whereas robots have limitless possibilities as to what they can sense around them. Humans might complain like, oh, we can sense if the temperature is hotter, but that's not really a sensor that keeps on going. It's kind of like a background sensor almost. It's something we recognize but don't really do something against. It's not something we process too often. When programming, it's hard to get exact measurements for the robot to move, so sensors can help the robot in the field rather than relying on approximations and programming. When you're on the field, for example, in regular robotics competitions, you might have a robot on the field that's like, oh yeah, you already have a set out field. But in real world examples, you don't have a set out field for your robot. Like in Mars, they never have they plotted out where the robot would be, but they never specifically saw how the robot would move around the terrain. So humans, rather than relying on the approximations of, oh, go forward 1.2135 feet, instead we can just rely on sensors, which can give us back more input and can, as I'm going to say now, become useful in many ways, and having more sophisticated sensors can automatically mean a task more efficiently done, can give back more precise measurements that will help with reprogramming the robot. So yeah, basically if you mess up something with the code, you can automatically reprogram it based off the sensors. And actually having more efficient sensors, sophisticated sensors, can automatically mean a task more efficiently done. Basically, having better sensors gives back better input for reprogramming the robot. So sensors in your house. So I'm just going to be walking through 3 different types of sensors in your house, which you probably know now. I must say, there are more than 3 sensors in your house, maybe 10, maybe 100. It's based off the type of house model, but still, these sensors are probably in your house right now, and I hope you guys can check them out after this video. So, believe it or not, there are actually many sensors in your house. So let's check a few out. So first off, the thermostat. I think this one's really obvious. A thermostat, yeah, not really a surprise, has a thermostat embedded inside. This makes sure that the temperature does not go too far out of the input temperature. If the sensor does detect this problem, it will start venting out the air necessary until the temperature is matched up. So the thermostat, the temperature will direct the temperature, it'll measure the temperature. When it sees that it goes too far out of the required temperature, then yeah, it'll change it back. It's based off the mode that you put it in. If, for example, the auto mode mainly does this, where if you set it to 72 degrees, for example, then it'll automatically go over to 72 degrees. And if the temperature goes too high or too low, or at least like 1 degree above, 1 degree below, then the thermostat will tell the microprocessor saying, oh, it's going too high, too low. And then the microprocessor will send out probably actuators and vent out all the extra heating air, use insulators, all that sort of stuff. So next, computers. Computers surprisingly have sensors inside to prevent overheating. Basically, whenever the computer gets too hot on the inside, a sensor detects this, like a heat sensor, and a fan switches on to cool down the computer. This is really important because without this fan, our motherboard will overheat and our computer won't be able to work. We'll have to get a new one. So the fan, which sometimes actually if you use your computer keep your computer on for a long time, process lots of things, this fan will actually turn on. So yeah, this fan will start to rotate, so you might hear that noise. And basically, yeah, this is a sensor, one of the sensors in the computer. Smoke sensors. Well, smoke sensors obviously are sensors used in your house because it is a smoke sensor. But smoke sensors basically use sensor to detect smoke that is coming inside the house. After this, they immediately puts on an alarm to get everyone out of the building. Then it might trigger water features and then alert the fire department, all because of detecting the smoke. Typically in a house, it'll just alert the people to get out of the house, and you'll see a few around your house. You have to change out the batteries. This is mainly for the sensor to detect, and if you have faulty smoke sensors, which you have to get replaced every not too often. But yeah, basically the sensors keep on detecting for smoke, and it uses certain like heat waves for all that. And even if it's just like you're cooking something and smoke is coming out, it'll still warn you. So you have to be aware of that. So now let's talk about the robot's effectiveness based off the sensors. So a robot's effectiveness is whether a robot is successful on the field or not. All the time, the success is based off the actuator, sensors, and end effectors and microcontroller effectiveness. So basically, it's based off these four things, which I have shown in my previous video. I just kind of shown how these four work together. And then because of this, sensors are 25% of the robot's success. That's why they should be included in a robot. So whenever you have a robot, it's best to have a sensor, even if that sensor is not inputting back to the brain, which I mean, still you probably should have it input back to the brain. Still, you should have a sensor on your robot so that at least you can get information and you don't have to apply anything right on the field. Like you don't have to have a distance sensor. It goes to 22.03 inches instead of 22.02 inches. You don't have to have a sensor to detect that and then move your robot back. That's not necessary. But instead you can just use a sensor to detect this, and then next time you can try and change your programming. But I really recommend using sensors, based your sensors off of the robot's effectiveness, because of how the brain sends programming to the sensors give information back to the brain, then the brain sends this information over to the actuators and tell them to do something, all based off the code. The actuators send back the end effectors. What happens? So let's just talk about sensors used in school robotics. So how do sensors relate to robotics competitions, those robotics competitions that you see all the time? So how do sensors relate here? So inserting a sensor can actually benefit teams based off the year's challenge. For example, I'm just giving a example. In the 2017-2018 VEX IQ Ringmaster Challenge, teams had to stack rings on poles, and to accumulate points even more, they had to stack same color rings. So in that case, during autonomous, teams could have used a color sensor to detect the color of the ring, and then react by picking up and placing it on the slot to gain points. So over here I have a video, and I'll just explain a little. Basically, in the video, it's not really the most efficient video because they are in driver control, they are controlling the robot, but I'm just kind of showing you a little of the game, how it works. And okay, yeah, basically they're trying to stack these, both teams are working together, they're trying to stack their, use their robot to stack, and these poles over here, they use those, utilize these poles, this pole over here, this pole over here, and this pole over here. They utilize these poles, and if they stack a correct amount of rings on it, like the right color, like this robot up here is doing, they do that, then they'll instantly gain more points, which is something to consider. It's always good to have sensors to help you with this. Okay, yeah. So yeah. So yeah, they're just kind of stacking through it. Not the best video, but this is the one I could find. And yeah, using this in autonomous would be a lot cooler and a lot more efficient. So yeah. So I really recommend yeah, using sensors is really important when it comes to robots. And right now we've seen in this example that the sensors came extremely important, especially when considering that they were on the field at that point. So yeah, thank you for watching this video, and remember to follow me on Instagram. Remember to subscribe and like the video. And if you just have any questions on my video, ask them in the comments. I'm free. Thank you.